Okay, this is video number 3 for two variable inequalities. You'll notice that there's no directions like step 1, step 2, step 3 off to the side of this one. And that's because with applications, there isn't really official steps that you need to follow. The challenging part and really the most important part you have to get going with is the constraints. So my recommendation to you at this point is to pause the video, go through and see if you can figure out what terms or vocabulary in here is going to help you with the less than or equal to, greater than or equal to part. Additionally, find any numbers that look like they belong together that you can wrap up into a single inequality. And then unpause the video and come back and see how you did with those. Okay, so I went ahead and grabbed my highlighter to take a look at where I would want to pair up things that look like they belong together. So I saw money. I saw a total of $120, more or less. We'll get to the vocabulary in just a second, but $120. So I searched through and find anything else that represented money. So I have the money that I would earn from the job at the store and the money that I would earn at teaching music. And then I have total money. So I think I need to write a money inequality. So I'm going to go ahead and put the money on the right-hand side. So I've got 120. I'm going to do $10 per hour at the store. You'll notice I identified the variables for you too. So we're going to use X for hours at the grocery store. I'm assuming we're working at both places, so plus. And then $15 per hour teaching music. All right, now let's go back up to the vocabulary word. It says we want to earn at least 120. So earning 120 is good, but earning more than 120 would actually be ideal. So that puts me at greater than or equal to $120. Okay, so that's the purple one. Now the next one that I highlighted was in green, and it's the only thing I highlighted in green, and that's because it is specifically about the grocery store and the number of hours at the grocery store. Okay, so grocery store is X. We're talking about 8 hours and at least, so working exactly 8 hours is good. Working more than 8 hours is also good. Okay, I mean, we want to make sure that we follow all of the constraints though. Okay, so that's that one. All right, now the next one that I did in blue, the blue implies the combination of the total hours that you're going to work that week. So we're assuming that we're working at both jobs. So we're going to take all of the hours from the grocery store plus all of the hours teaching music. And let's say 20. Okay, so 20. We want to work no more than, so we don't want to work more than. So working exactly 20 is good. Working less than 20 is also okay. All right, I think we've got our constraints. Now, we need to actually graph these things. So let's manipulate our purple inequality here, just trying to get the y by itself so we can graph it. So the 10x's go away. Let's drop the 15y. Subtracting doesn't do anything, so the inequality sign stays the same. And divide by 15. Okay, using my calculator, dividing by a positive doesn't do anything to the inequality symbol either. We can actually simplify this in the calculator. So if you guys type in -10 divided by 15, it's going to give you a decimal. But that's okay because there's a button right next to the answer. And if you click on that button, it'll turn it into a simplified fraction for you, which is actually pretty nice. If we type in 120 divided by 15, though, that's 8. That actually works out nicely. All right, so let's go ahead and graph this. But before we do that, we need to make sure that we label the axes. So we said X was going to be the number of hours at the store, which I already have at the bottom there. And then Y is going to be the number of hours teaching. So let's go ahead and label this. All right, now we can graph it. Okay, so this is going to start at +8. And then it's got a -2/3 slope. You'll see that I have the increments on both the x and the y-axis is the same, so I can just count the boxes when I do the slope. So -2/3, -2/3, thirds, all the way across my graph. Now, we've been really good about making sure that we extend our line and draw arrows, but we don't want to do that this time because having negative hours at either job doesn't really make any sense. I did take a look at my inequality and see that it was supposed to be dashed, and then I have to shade this thing. So y is greater than. All right, greater is going to put me up. So I'm going to go ahead and shade up in this direction. Y is greater. Okay, after I shade that, I've got the first one on the graph. Now let's get the next one on. Okay, the green one, I don't really have to do anything to manipulate it. So let's go to 8 on the x-axis. 8 on the x-axis. It is supposed to be a solid line. So let's go ahead and put our solid line there. Oh, it's off a little bit. I'm going to extend it up. Okay, now from here, it says x is greater than. So that's going to be to the right of the green line. Remember, I'm looking for the overlap in the shading. So where it's not going to overlap, I'm probably going to erase. Because once I get more than 2 inequalities on here, it kind of gets a little messy, and it might be hard to see where the answer is. So where it's purple right now, but not green, so no overlap in shading, I'm going to get rid of that. So again, I'm trying to figure out where all of the shading overlaps. Okay. All right, now moving on to the next one. Okay, so the blue one we're going to have to manipulate just a little bit. So let's go ahead and move the x to the other side, trying to get the y by itself. Subtracting doesn't do anything to the inequality. And I like to have the x come first, so I've got slope. Okay, so let's start at positive 20, and then we have a negative 1 slope. So down 1, right 1, and work our way across the graph. And once we have that, I'm going to determine if the line is solid or dashed, and then we're going to shade this thing. And hopefully we'll be able to see where all of the shading comes together. So where the solution is for every single one of them. Okay, so this is going to be a solid line. So let's go ahead and put a solid line through the blue dots. Okay, then it says y is less than or equal to. So we want to be below the blue line. So that means I'm going to shade in this direction. This direction. I only want to shade where the other overlap is though. So I'm going to be below the blue line, but where the purple and the green are already located. So that is going to be the overlap in my shading here. All right, now let's get rid of the extra shading. So where it's only purple and green, but not blue. Remember, we don't want to be on both sides of the boundary. You're either above it or below it. You're either to the right or to the left. You can't be on both sides. Okay, so on the blue line, notice we are strictly below it. Notice on the green line, we're strictly to the right of it. And on the purple, we are strictly above and to the right of it. Okay, let's see if we can answer the question now. So write the constraints. Done. Graph the system of inequalities. Done. Determine whether you can work 8 hours at the grocery store and, ooh, that's a typo. Let's get rid of the teacher part and teach 1 hour of music. Okay, so we're looking for 8 for the grocery store. So I'm going to go to where 8 for the grocery store is, and then I'm going to go for 1 for teaching, and I'm going to come together where those guys are, 8 and 1. So that's that big black point. No, I don't think I can. It doesn't satisfy the inequality. So can I do that? No. Based on the constraints, I cannot work 8 hours at the store and 1 hour teaching music, because it doesn't satisfy all of the constraints or all of the inequalities. Remember, the only thing that satisfies all the constraints or all the inequalities is within the shaded region where all 3 of the shades came together.